Good day. I am Alexander Polukhin from Shirshov Institute of Oceanology. I greet all conference participants and I am pleased to perform the work Modern State of the Aragonite Saturation and Carbon Dioxide Fluxes in the Kara and Laptev Seas. This is a joint research of Shirshov Institute of Atmospheric Physics, St. Petersburg University and Lomonosov Moscow State University. Climatic changes taking place in the Arctic are visible to the naked eye. However, they are recorded by a large number of scientists in various fields of science. These changes include the carbon cycle in the Arctic seas. And if there are not very many factors of these changes in the open Arctic, there are a lot of them in the coastal areas. Richard Belliber's picture from Ocean Acidification Without Borders paper in Nature Climate Change in 2017 showed this really well. The carbonate system is significantly influenced by the sum of physical, chemical, and biological factors. One of the main features of the Kara and Laptev seas is continental runoff. Kara Sea has got 41% of total runoff into the Arctic Ocean, which is approximately 1,500 cubic kilometers of fresh water per year. From this value, 45% belongs to the Yenisei River, and 35% belongs to the Ob inlet waters, including the Ob River and some other smaller rivers. The Laptev Sea has got 25% of total runoff into the Arctic Ocean, or approximately 800 cubic kilometers of fresh water per year. From this value, 73% belongs to the Lena River, and 13% belongs to the Khatanga River, which is located on the very west of the Laptev Sea. As the data show, the flow of river discharge into the Kara Sea is increasing, mainly due to the Ob and Yenisei rivers. The supply of inorganic forms of carbon also increases. Accordingly, the river bloom is a source of CO2 into the atmosphere. However, its distribution depends on external factors such as wind force and runoff volume. This data was published in the Environmental Research Letters in 2019. Nevertheless, the average data on saturation with calcite and aragonite show that for the surface layer of the Kara Sea, both of these parameters decrease over the period from 2007 to 2021. The main factor of this variability is the increase in river discharge. In the Laptev Sea region, we have data on the dynamics of the CO2 content in the atmosphere since 2011, and we see that it is growing. In the work of Natalia Shakhova, it reported that the shelf of the East Siberian Seas is a source of methane due to the seepage from the sediments layer. And in the work of Igor Semiletov and colleagues, on the basis of long-term observation data, it is shown that a large amount of terrestrial organic carbon from melting permafrost enters the sea with river runoff. This fact explains the low saturation with aragonite in both the surface and bottom layer of shelf waters. Thus, the process of acidification is going on quite intensively, which in the medium term can lead to irreversible consequences. Shirshov Institute of Oceanology started its program Ecosystem of the Siberian Arctic Seas program under the leadership of academician Mikhail Flint since 2007, and the pilot cruise was held in 1993. Since that time, our institution has got 11 cruises to the Kara Sea. In September-October 2017, we investigated the area of the Kara, Laptev, and East Siberian Seas. In 2018, we have investigated the area of the Kara and continental slope of the Laptev Sea. And in July 2019 and in September 2020, we have investigated the Kara Sea area. It's mostly its central and western parts. So one of the most interesting cruises was in 2017 when we have got to investigate all 3 Siberian seas. We have calculated the freshwater part using surface salinity data, and we see that the most amount of freshwater located near the rivers. We have calculated the partial pressure of CO2 along the movement of the vessel from the Kara to the East Siberian Sea. In water areas affected by river runoff in the eastern river plumes, PCO2 significantly exceeds the equilibrium value, as well as the content in the air. Therefore, the flow is directed to the atmosphere. In the western part of the Kara Sea and in the area of Velkitsky Strait, it's indirectly seen that the flow is directed into the water. We have also calculated the saturation of the surface layer of the sea with aragonite. Values below 1, as in the case of CO2, are observed in the river plumes, and values above 1 to the west of Yamal Peninsula and in the Velkitsky Strait. In the central part of the Laptev Sea shelf, the alkalinity-salinity ratio clearly shows the influence of the Lena River water. It is expressed in a reduced aragonite saturation, 1.2 and less. The partial pressure of CO2, on the contrary, is quite high, and it is explained by the income of a large amount of organic matter against a background of low photosynthetic activity. In the western part of the Laptev Sea, the influence of the Khatanga River is expressed. River waters spread over a distance of about 200 kilometers from the mouth of the bay. As in the case of the sea shelf, there is a low aragonite saturation up to 1.8 and a high partial pressure of CO2, which reaches values in equilibrium with the atmosphere already in the ambient sea. Studies carried out in the area of the continental slope of the Laptev Sea in the fall of 2018 revealed a heterogeneous structure of the distribution of aragonite saturation from 0.9 to 3.1. This distribution is clearly influenced by mixing of different water masses. The same applies to the distribution of CO2. In the surface layer, high values are a consequence of photosynthetic activity. The influence of river runoff closer to the Velkitsky Strait on the right pictures is also noticeable. The hydrological structure confirms the interaction of several water masses, like summer surface water, intermediate winter water, and Atlantic water. We have calculated the flow of carbon dioxide in the area of the continental slope. On the outer shelf, above the slope and at the deep water part, the CO2 flux is directed mainly into the atmosphere at a rate up to 4 millimoles per square meter per day. Above the slope adjacent to the Velkitsky Strait, the flow is already directed from the atmosphere into the water at a speed of up to 12 millimoles per square meter per day. The inner shelf of the Kara Sea, adjacent to the mouth of the Ob Inlet and the Yenisei Gulf, is also characterized by a strong influence of the river runoff on it. This is reflected in the low saturation of shelf waters with aragonite. Saturation values vary from 0 in the riverine part to up to 2 closer to the shelf boundary. In September 2020, we conducted surveys on the shelf slope adjacent to the St. Anna rock. There is a stable frontal zone which we observed for many years. It's formed when the waters of the shelf interact with the current from the western part of the sea, moving along the slope to the northeast. The frontal zone is distinguished by a sharp temperature gradient, which is reflected in the distribution of aragonite saturation and partial pressure of CO2. Extremes of CO2 in water and atmosphere are observed at the boundaries of this zone. We calculated CO2 flux rates for the Kara Sea in July 2019 and September 2020, expressed in moles per year. It turned out that in July, almost all the entire investigated water area is a sink for CO2 at a rate up to 30 moles per square meter per year. The mouth of the Gulf of Ob stands out, where the release of CO2 into the atmosphere from riverine and freshened waters reaches 80 mol per square meter per year. In September 2020, the CO2 flux was directed into the water in the coastal zone of Novaya Zemlya, in the area of the continental slope. The inhomogeneity of the flux is determined by the complex hydrological structure of the waters. Values range from -8 to 12 mol per square meter per year. On average, over these 2 years, the Kara Sea is a sequester of atmospheric CO2. To wrap up, our main conclusions are: the process of acidification is occurring in the Kara Sea. A riverine plume is a source of carbon dioxide during intensive runoff both in the Kara and Laptev seas. The continental slope of the Arctic marginal seas is a sink of carbon dioxide. Features of the distribution of carbon dioxide are associated with both physical processes, like mixing of water masses, and biological productivity in the surface layer. In the future, the influence of the dynamics of the carbon dioxide flow on the carbonate system of the Kara Sea, as well as Laptev Sea in general, as well as on the acidification process in particular, will be studied. I'd like to thank you for your attention. Here's my email and ResearchGate profile, and I would like also to thank the Ministry of Science and Education of Russia and the grant of the President program for funding these investigations. Thank you and goodbye.